with what we have here, right? It says determine the value of the following expression. So what that means is choose. If you're gonna determine the value of this, it means they just want you to like break it down until it's like it's probably like a number. So the first thing that stands out is the fact that this is the double angle of sine. I don't know if you can see it, but I think you can. If you have your formula sheet next to you, you'll see that you have a double angle of sine over there. You see, like sine 2
I just
alpha.
said.
Oh, no, yeah, sine 2 alpha is equal to 2 sine alpha and then cos alpha. So this is just double angle of sine. If we ever need to change it, we can do that. But yeah, one or the other, with all this tan that we see, yeah, we might not end up what you call doing what we think we might end up doing. But let's just see what this question is going to come out as. So the first thing that I may want to do, yeah, let's just deal with the 10. The 10 at the bottom first, actually, and you'll see why. So remember this here, you have 2. Let me actually make this a bit bigger. You have 2 sine x, right? And then you have cos x. Then you have 1 plus 10 squared x. So the 10x at the bottom here, remember, it's actually just sine x over cos x. You remember? You remember,
I think
right?
I think I do.
You
I
think you
think I
do?
do.
Let me just write it down here.
I'm
So
sorry,
it's
my
like
brain
10x
is mush.
is equal to sine x.
Oh. Yeah, I remember.
Yeah.
We just did it. I'm sorry.
No,
But then
shit.
wait.
So the
Oh
thing,
yeah, that's why I hesitated because of the squid. What's gonna happen to the squid?
well, no. We're talking about the one at the bottom.
Oh,
It
okay.
doesn't have a square, you see. So you don't
I
have to
thought we
worry
were talking
about it.
about the one at the top.
Yeah, this one, what I'm trying to do is this one, you see, anything that's like a bit too compounded, you can just actually leave it until there really is a need to change it, you see. So for example, if you think of it nicely, right, what I wanted to show you is that you see here the 2 sine x and the cos x, it's being multiplied by this bracket, yes, but then this bottom part we can actually do something, because if you look at it nicely, right, what you can always do is, if you're dividing by a fraction, right, the only way you will be able to cancel out is by doing the following. Anything, right, if you're going to divide by a fraction, what you need to do is, this is how you need to visualize it. Let me show you. 2 sine x, right, and cos x. You have all this at the top. Now all this at the top is being divided by a fraction. Now remember, anytime you divide a fraction, you flip it over and then you times. You remember?
Yeah.
Yeah, so you're gonna flip it over and then you're gonna multiply. So you're gonna have your 2 sine x cos x and then 1 plus 10 squared x. So because we are multiplying with a fraction, you can make this a fraction also. The reason for doing that is so that you can just see that, okay, this sine x can cancel this sine x down there. And then everything at the top, if you multiply together, you have 2 cos x times this cos x, cos squared x, 1 plus 10 squared x, like that. Are we on the same page?
Yes, we are.
Nice. So the I think the only consolation here is that you can see we have things that are squared. There's cos squared here, and then 10 is also squared somewhere there. So the one thing you can do is you can now like multiply inside your brackets. So you're gonna have 2 cos squared x there. To multiply inside, if you multiply again, you're gonna have plus 2 cos squared x with the 10 squared x. So now, remember, we're trying to get it to like a single value, right? So this is where you can now change this 10 squared x. So the thing with 10 squared x is, if this is squared, right, these just both have to be squared also, because the idea is the same anyway. So we have here 2 cos squared x plus 2 cos squared x. And then this is like, what do we have there? This is sine squared x, the whole thing over cos squared x. You see? So the cos squared x cancels the cos squared x, and then you have 2 cos squared x plus 2 sine squared x. And then from here, remember, you're trying to just carry on until you're done. So you can check out a 2 as a common factor. So 2 goes out, you're gonna have cos squared x plus sine.
Cos x.
Yeah. And then this is the square identity. So cos squared x plus a sine squared x, that's just a 1. And then 2 times 1 is just a 2. So that's why they said that's why they ask you for a value of that expression, because they knew that if you work it out, you will end up with like a specific number instead of just an expression or something like that. You would end up with like a specific value. Okay, you get it?
Yes, I do.
Okay. So let's do that next one now.